In this lesson, we'll learn to solve a system consisting of a linear equation and a quadratic equation. Let's get started. Here, the given system is x plus y equal to 7. That is a linear equation. And another quadratic equation is x square minus xy plus y square equal to 13. By solution, we mean we will find the points of intersection. So, in order to solve such a system which has a linear equation and a quadratic equation, we always find the value of x or y from linear equation. From equation 1, we'll find either value of x or y, doesn't matter which one. X is equal to 7 minus y. And substitute this value of x, this value in equation 2, in the quadratic equation. So once we do that, we'll get, instead of x, now we can write 7 minus y. So this will be 7 minus y square minus, again, instead of writing x, we are going to write 7 minus y. 7 minus y into y plus y square is equal to 13. Now this equation involves only one variable, which is y, because we have replaced x by its value in terms of y. Now let us do the simplification, and here we'll use the a minus b whole square formula. So this will become 49 plus y square minus 14y minus 7y plus, still it will be minus y square plus y square equal to 13. And now we can simplify it further. 49 plus y square minus 14y minus 7y plus y square, because now negative time negative will become plus y square again, plus y square equal to 13. So we have expanded to the maximum possible. Now we will summarize this and add up terms which can be added. Y square could be added. So this will give us 3y square. And minus 14y and minus 7y will become minus 21y. And we have plus 49 and minus 13 when we bring 13 on the left side. So this will be the required equation. So this is 3y square minus 21y, and 49 minus 13 will give us plus 36 equal to 0. If we divide this equation throughout by 3, dividing this equation by 3, because each of the number in all three terms is divisible by 3. So this will further simplify our procedure. So this will become y square minus 7y plus 12 equal to 0, which is a quadratic equation and which can be easily solved, which is quadratic. quadratic in y. And now by factorization we'll write this as y square minus 3 plus 4 times y plus 12. If you are just joining from this lesson, you should go back and learn the factorization method from the solution of quadratic equation and then come back. Here this will be y squared minus 3y minus 4y plus 12 equal to 0. And if we take y common, this will give us y minus 3 minus 4 common, y minus 3 equal to 0. This gives y minus 3 into y minus 4 equal to 0. So we have y is equal to, since the product of two real numbers can only be equal to 0 if at least one of them is equal to 0. So either y minus 3 is equal to 0 or y minus 4 is equal to 0. If y minus 3 is equal to 0, then y is equal to 3, and here y is equal to 4. Since what was the substitution we made in the start? In the start, this equation which we substituted, let's call this as number 3. So from equation 3, x is equal to 7 minus y. So let us, since x is equal to 7 minus y, and now we have value for y, so let us substitute that value. And if y is equal to 3, then x is equal to 7 minus 3 instead of y. This will give us 4 as answer. So either in the solution set, one possible pair or one possible point where this quadratic equation and straight line might intersect is the point 4 for x and 3 for y. So that will give us that ordered pair, which is a possible point of intersection. And similarly, for the second value of y, again, we have x is equal to 7 minus y, and this will give us 7 minus 4, and this gives value of x equal to 3. So the second pair is 3 over 4. And if there is a straight line that is intersecting a quadratic equation, that must intersect in 2 points unless it is a tangent line to that quadratic equation, and in that case that will be the one point which will be a double point of intersection. But anyways, this is the solution, and let's do one more example in order to make it more clear. So example number 2. Given system is this time it is 2x square minus 2x square minus 4xy minus 4xy minus y square minus y square equal to 6, and the straight line associated with this is 2x minus y, 2x minus y equal to 4. So let us call this as 1, call this as 2. Like we said earlier, always get a value of one of the variable from straight line or an equation of degree 1 and substitute it in the other quadratic equation. From equation 2, we'll find value of y. 2x minus 4 is equal to y. The reason, because if we find value for x, that will give us fractions and that will just make our job little difficult. So just go with the variable which has value which involves only integers. So now substituting the value of y in equation 1, substituting value of y in equation 1, we'll have 2x square minus 4x. Instead of writing y now, we are going to write 2x minus 4 minus, instead of writing y again, we are going to write 2x minus 4 whole square equal to 6. So now let us open these squares and simplify the given equation. This is 2x square minus 8x plus 16x. So this is minus 8x square plus 16x minus, and if we apply the formula, this will become 4x square plus 16 minus 16x equal to 6. So now let's simplify this further. This is 2x square minus 8x square plus 16 minus 4x square minus 16 plus 16x. Due to multiplication of negative inside the bracket, all the signs inside the bracket will change and this all will be equal to 6. Collect the like terms. 2x square and minus 4x square are like terms, and here is minus 8x square again. So minus 4x square and minus 8x square will become minus 12, and plus 2, that will give us minus 10x square. This is because this term, and this term are like terms and they can be added, resulting in minus 10x square plus 16x. And take a look on any other term. Here we missed this x. This was 16x. So this 16x and this 16x will become plus 32x. And here, what is the constant number is minus 16. Minus 16 and minus 6 when moved to left side is equal to 0. So this is minus 10x square plus 32x minus 22 equal to 0. And dividing throughout by minus 2, dividing throughout by minus 2, that will give us 5x square minus 16x plus 11 equal to 0. So this will be the required equation in simplified form in one variable, and we are well used to finding solution of a quadratic equation by applying any of the method, either quadratic formula or factorization. So this will be equal to 5x square minus, instead of writing 16, I'll be writing it as a sum of 5 and 11, x plus 11 equal to 0. And here we have 5x square minus 5x minus 11x plus 11 equal to 0. This gives us, if we take 5x common, x minus 1 minus 11 common and x minus 1 equal to 0. And if we take x minus 1 as common, inside is 5x minus 11 equal to 0. The product of real numbers is not equal to 0 unless one of the factors is 0. So either x minus 1 is equal to 0 or 5x minus 11 is equal to 0. If this is so, then x is equal to 1. And if 5x minus 11 is equal to 0, then x is equal to 11 over 5. Again, if you remember, y was equal to 2. When we started the solution, that's what we substituted the value. Let's call it as equation number 3. Y is equal to 2x minus 4. So y is equal to 2x minus 4, and here again y is equal to 2x minus 4. And now if we substitute the value for x, which is 1 in this case, minus 4, and this is 2 minus 4, that will give us the solution minus 2 for the value of y. So you can see that when x was equal to 1, y is equal to minus 2. Thus, the solution set will be equal to, for value of x equal to 1, for x equal to 1, y is minus 2, and when x is equal to 11 over 5, we can find the value for 2 times 11 over 5 minus 4, and this becomes 22 minus 20 over 5. This is equal to 2 over 5. So y, if x was equal to 11 over 5, when x was equal to 11 over 5, y is equal to 2 over 5. So these are the two required points of intersection of a straight line and a quadratic equation when they intersect each other in 2 points.